Okay, now we're on section 6.2 of your workbook. It's page 75. We have scientific notation that we're looking at here. We use this for extremely large or small numbers. They're in this form here, a times 10 to the n. We like to use this actual time symbol, the x there. It's not representing a variable, it just means times, okay? Where a is between 1 and 10, not including 1 and 10. N is our exponent that we have. It's either going to be positive or negative, depending, if it's a small number or a large number. So there's all these notes that you should read through. And you've probably read through that in your text, but it's just handy to have here in your workbook too. So case 1 and case 2 we'll look at in the examples. So here we're converting numbers into scientific notation. And starting with what we call standard notation, or sometimes people might say expanded or something like that, or just, like your typical number. So we have 8,150,000 that we want to turn into scientific notation. So we know we have to have this a value between 1 and 10. So I'm going to need to make that be 8.15 times 10 to the something, right? We don't know what that's going to be, but we can figure it out. So if there's no decimal point showing in a number, it's understood to be at the end. And in order to get this decimal point way over here, I would have to move left, or really what I'm doing is dividing the number. 1, 2, 3, 4, 5, 6 places left by multiplying by a factor of 10 to the 6th. So it really still equals the same number. So just what you need to know is 1, 2, 3, 4, 5, 6 places left. That means your exponent needs to be a 6. And it will be positive because we're taking a very large number and we are putting it into scientific notation. Okay, so I just want to point out this should really be divided by a million is what we did. And just to show you how that works, so we're dividing by a million here to get this to look like 8.15. But if we don't then multiply by a million, we've changed the value. We just have like a little tiny number if we didn't have this piece here, right? So it's kind of like if I have the number 30 and I want to have it be in scientific notation, I divide by 10 and I would get 3. But clearly 3 is not equivalent to 30. I mean, it's just easier with a smaller number, so I'm showing you. So I would have to multiply by 10 to the first power in order to have it still be the value of 30. So I want you to keep that in mind as we go through and make other adjustments sometimes. So here we have example 6.15, convert 0.0000245 to scientific notation. So now we want to get our decimal all the way over to here so that we have 2.45, so that a is a value between 1 and 10, right? In order to do that, I would need to actually multiply or move right 1, 2, 3, 4, 5, 6 places. But I actually need to write this as a division, as a tiny number, right? So that it compensates here. So if I'm multiplying by 10 to the 6th is what I'm really doing here to get it to look like 2.45. In order to keep the same value, I need to multiply by 10 to the negative 6. So again, I'll show you like a little side example with smaller things to deal with, or just not even smaller, actually, just an easier number. So I guess we'll stick with 3 here. So if I have 0.3, that's 3/10, right? But I want to put that in scientific notation. and 0.3 is below 1, so we can't have that. We need to actually write it as 3. And in order to get 3/10 to equal 3, I need to multiply by 10, right? But to keep that balance of my value, if I just multiply by 10 and leave it as that, that's just equal to 3, not 0.3. So I need to then also multiply by 1/10, which is the same as 10 to the negative 1. So that's what I'm doing there to keep the same value, right? Now we're going to go the other direction. So page 76 of your workbook, convert numbers from scientific notation to standard notation. So if we have this form, a times 10 to the n, then we can follow this rule of thumb. If n is positive, that means it was greater, the original number was greater than 10, right? So we're going to move the decimal to the right n times. So that's going to be a really large number. And if it was negative, that means the original number was a small, tiny number, less than 1, but greater than 0. So we're going to move the decimal to the left n times. We don't have negative numbers with scientific notation. If we have something that ends up being a negative, it would be like pulled out as a coefficient, like a multiplier. They're not considered in the a value, right? So for this one, if we want to go back to how it looks in regular standard notation, we have to multiply the number by 10 to the 5th power. And just to note, that is the same as 1 with 5 zeros. So we're multiplying by 100,000. Okay. And when we multiply, we just move right. That number is 0. So it's kind of, you've probably done this before. So I just kind of shift over 1, 2, 3, 4, 5. And then I know I have 5, 2, 3. And then I have 1, 2, 3 zeros. Now you can track that any way that you want, that works for you. It's kind of similar to when we were doing the unit analysis and we had conversions for the metrics and we use that conversion bar. It's just might kind of seem a similar process. And that's it. We can check against. Did 5.23 times 100,000? You can even check that out on a calculator and make sure that works for you. Now we're going to look at example 6.17, and we have 4.25 times 10 to the negative 4th. So I know that should have originated as a tiny number. So that's when I put it back into standard notation, I'm really dividing by, or which is the same as this, 1 over 10 to the 1, 2, 3, 4. Okay. Dividing by 10,000 is the same as multiplying by 1 over 10,000. And so I'm going to move 4 places. 1, 2, 3, 4. So I have 0.0004. So make sure it's 4 places, including like the one right before the decimal. 2, 5. And then put a 0 in the front. And that would be my answer. 0.000425. Now, hopefully that was a review for you, that you've kind of done that back and forth before, but maybe you haven't seen the conceptual piece that I was talking about before. But now we're going to do some operations with these numbers. And we're going to use our skill of exponent laws, or our skill of exponents, and using, applying our properties and things like that. So Multiply and divide numbers in scientific notation. Rewrite the factors as multiplying or dividing a values, then multiplying or dividing 10 to the n values. So remember, I was saying this is kind of similar to if you had like a number in front of your exponential. Say you had 2x to the third power, then the 2 is kind of similar position of the a. It's that factor. And then you're going to multiply by the exponential, which is the 10 to the n in this case. And you're going to just we're going to group those and separate them out. Then you're going to just calculate the product or quotient of the a values and the product or quotient of the exponentials. Then once you're done, you have to put it into scientific notation to get full credit. So that's really important. A lot of times they'll come out not quite there. You'll get like maybe 22 times 10 to the third power, and that's not in scientific notation. It may kind of seem it, but 22 is bigger than 10, so technically it's not, right? So we have to adjust that. So we'll look at how we work with that on some of these. The first two, though, are more straightforward. So here I have, I'm on page 77. Example 6.18, multiply and write your answer in scientific notation. So here I have these values. I have 3.4 times 10 to the 5th times quantity 2.7 times 10 to the negative 2. So I'm going to perform the operation of the coefficients, or the a values first. So I'm going to use the associative property and just kind of group those together over here, group my a values. So you can see how this is done. And then it'll be times, like the x that we write for times. And then I'm going to deal with my exponentials. So I keep my base is 10, and I add my exponents if I'm multiplying. So 5 plus negative 2. Then I would calculate my a values, and I get 9.18. And then I calculate this. It would be 10 to the third power. Okay, so we get 9.18 times 10 to the third power, and that is all good because 9.18 is less than 10, but bigger than 1. So that's a keeper. You can, if you want to stretch these values out up here and then calculate them and see if you get the same thing, you could check your answer that way. But a lot of times people just get really hung up on that, and it takes a lot of time and not generally a good idea unless you're just trying to figure it out conceptually. So now we're looking at example 6.19, divide and write your answer in scientific notation. So again, we're going to deal with the coefficients first. So we're going to pull those out and calculate. Then we'll have 10 to the 4 minus 3, or minus negative 3. Because remember, we're subtracting when we have the quotient rule, okay? Okay, so now we have 2.8 times 10 to the 7th. So I will say a common mistake that people make is that they just do 4 minus 3 here, and they give me 10 to the first power. So be careful of that. Remember, you may have like a double negative situation that you need to watch for. I have trouble with my little boxes there. So let me know if you have questions on this. You can email me, but hopefully that is something that even this you're not seeing for the very first time. Maybe you haven't worked with it much though. Okay, so now we just have 2 more problems. Page 78, example 6.20 and 6.21. I think you have enough skills here to do this one on your own as a classwork. But I will tell you that we need to make an adjustment at the end, though. It's going to get into a format that looks like scientific notation, but your answer will not have the A value in the right range that we're looking for, okay? So, or number, it's not between 1 and 10. It's going to be different. So you're going to have to see if you can make that adjustment, but check back with me and I'll help you through that. Same thing here. So you can start to get this set up for these two and see what you can do on your own. So pause the video and do that, and then I'll go through it with you. Okay, so you can see my answers here. I just multiplied the A values, then multiplied by the exponential. I have 10 to the negative 6 plus negative 3, so I get 10 to the negative 9. So I end up with 34.84 times 10 to the negative 9. This is not in scientific notation because it's larger than 10. So I have to make a little adjustment here. So if I have to divide by 10, basically shifting left to make that be 3.484, then obviously I need to do something over here, right? I need to multiply by 10 or kind of shift right, so to speak, to make this be 10 to the negative 8. Okay, so this is decreasing by a power of 1, and this is increasing by a power of 1. So this would be my final answer. So you might want to write yourself a little note. So I have to decrease by power of 1, 10 to the 1. So power of 10 really. And then this is increase by power of 10 to the 1, okay? Or a factor of 10, you could think of it. Maybe we'll write by factor. The power, the exponent has to increase by 1, which is technically the factor 10 to the 1. So this will be our final answer, and that is all good. Okay, last one for this video section. We have 2.352 times 10 to the negative 6 divided by 8.4 times 10 to the negative 2. So we divide our A values first, and we get 0.28. Then we divide our exponentials here, 10 to the negative 6 minus negative 2. So that's like negative 6 plus 2. So I get 10 to the negative 4. So again, I don't have my answer in scientific notation, but I can get it that way. In this one, I actually have to increase by 10 to the 1. So this one I have to decrease by 10 to the 1. So I'm going to subtract 1 from there. So this exponent is actually going up. So it's 2.8. And this one is going to be 10 to the negative 5. So I'm decreasing by 10 to the 1, which is the same as dividing by 10 or multiplying by 10 to the negative 1. And then this would be my final answer. One thing I want you to keep in mind when you go into your next course, we are going to have proctored midterms and finals for most of those classes, like Math 99 and Math 141. So you will most likely have a situation where you have to do these without a calculator. There's often no calculator portions of the test. So the numbers would work out easier, though I wouldn't put ones like these. I would probably put like, for example, I might have like 3.2 divided by 8 or something like that. So you have to know how to go in and do the long division that way. So make sure when you're in those classes and you expect it to practice, or even if it's a prereq skill, so some of these you should be doing without use of a calculator for basic operations. Okay, that's very standard. And as you go up through calculus, a lot of times instructors will have no calculator at all, even for like physics and things. They just make the numbers work out pretty okay, but the calculator can do so much, like give you derivatives and graphs and all these kind of things. So we don't allow it, you know, for logarithms and stuff like that. So be cognizant of that as you're working. Have a great day.